Here we go. Okay. So, we have talked about 6-1 and 6-2. What did we talk about in 6-1 and 6-2? The mid-segment theorem. Yeah. How it's what compared to the parallel side? What is it? 1/2. Good. It's 1/2 the length of the parallel side to it. So we talked about those. Now we're going to talk about something called circumcenters. A circumcenter. Always one. There's always one.
Golly, Abby!
You looked at me, Peter.
What?
Circumcenter. Okay. So we had to talk about what this is and what this looks like. Now listen. The rest of this chapter gets a little bit tricky because it's a lot of vocabulary and a lot of things that have to be drawn out. If you don't draw it out, you will not know what is going on. Okay? So on triangles, there are things called circumcenters. And we can create them, but we have to create them through specific types of things. So let us dig in real quick. Okay? There's something called a point of concurrency. And a point of concurrency is when bisectors meet at a single point. Okay? Bisectors meet at a single point. How many bisectors are there in a triangle?
1.
Incorrect.
I guess you'll do 3.
Three.
That goes, oh yeah, you're right. Go, yeah.
Yeah.
Okay? There are 3 bisectors, right? Okay, because there's 3 sides, so I can have 3 perpendicular bisectors, like on the sides, or I can have 3 angle bisectors, correct? Okay, all of these are different. So circumcenter has a point of concurrency, and the point of concurrency is when the bisectors meet at a single point. Concurrent segments or concurrent rays or concurrent lines. They're all the same. They're all referenced. What, Abby?
Point of concurrency, is that like a vertex?
No, because, well, kind of. They could come to possibly create a vertex, yes. But it's just where all the bisectors overlap and meet. Current segments, concurrent rays, or concurrent lines are the bisectors. So it depends what we have going on. Will tell us if it's a concurrent segment, a concurrent ray, or a concurrent line. Okay? What are you doing?
I'm just adjusting my chair.
How you know?
Okay.
Mark, are you really?
Okay. Concurrency and perpendicular bisectors theorem. Okay. The perpendicular bisectors of a triangle intersect at a point which is the same distance from the triangle's vertices. The perpendicular bisectors of a triangle intersect at a point which is the same distance from the triangle's vertices. Okay, so look, you see this right here, ED, FD, and GD. Those are the perpendicular bisectors, yes?
Yeah.
Where they meet right here at point D is called what? What is that called? Where they meet at point D is called what?
The concurrency.
The point of concurrency, okay? Because those perpendicular bisectors meet at point D, that's the point of concurrency. If DE, DF, and DG are perpendicular bisectors, then that means that AD, DB, and DC are all congruent. Look at how many nice triangles we have now.
Yeah.
We can start to solve some
You didn't
stuff.
have that word.
I'm going to switch slides because it's going to show you this. It's going to show you the same thing with colors. Calm yourself down. Okay? So the perpendicular bisector in a triangle, see this is the same rule right here, okay? When DE, DF, and DG are the perpendicular bisectors, then that means DA, DB, and DC are congruent. Now, on an acute triangle, see right here, on an acute triangle, the point of concurrency happens where on that triangle? Yeah, point C, which is inside the triangle. When you have a right triangle and you're doing perpendicular bisectors, the point of concurrency happens on the hypotenuse. And when you have an obtuse triangle, do you see how the point of concurrency is outside of the triangle? Because you're drawing perpendicular bisectors to each side. So when I have a perpendicular bisector of this side of this triangle, of that line, and how do we draw perpendicular bisectors again?
You,
Oh, I got it now, I got it
you
now.
draw a line, and then you pick 2 points, and then you draw 2 arcs.
And they make sure they're not-
Yeah.
Oh,
Two
yeah,
rings,
yeah.
you draw a line.
So how many times would you have to do that on
3.
these? 3. And then when you draw that straight line through, they're gonna meet at the points of concurrency. If it's an acute triangle, they're gonna meet inside the triangle. If it's a right triangle, they'll meet out on the hypotenuse, and if it's a obtuse triangle, they'll meet outside of it, yes.
So we're gonna need our like compass or what?
You
what's it
could
called?
possibly, because here's the deal, sometimes they're gonna give it to you like in a picture and you have to name stuff or do stuff. Sometimes they're gonna ask you to create it, so yes, it's possible.
Can't we just look at it?
No, trust me on this, then there's a reason why. Let me tell, can I explain why?
Yeah.
Because we don't just have,
May not-
perpendicular
may not be
bisectors.
on your scale.
We have another thing that we're gonna learn, so this is 6.3, this is called circumcenters. Circumcenters happen when you have perpendicular bisectors. In 6.4, we have something called centroids and orthocenters,
No, thank you. Centroids?
centroids and orthocenters.
Like an
And
ortho-
those happen when you have, medians.
Isn't ortho-
And then in 6.6,
orthodontist?
we have something called incenters, and those happen with angle bisectors. So, you're not going right now.
Okay.
So,
Oh,
so that's why we can't just look at it. Because here's the deal, when we have incenters later on in 6.6, it's going to look very similar to this, because you're gonna see perpendicular segments. But the problem is, you're gonna have to realize that that's coming, the actual thing we're looking at is the angle bisector, not the perpendicular segments. On this, on circumcenters, we are looking simply at the perpendicular bisectors and where they meet. Because the angles are not cut in half, correct? They're not labeled that way, we don't know that, okay? But we do know that the perpendicular bisectors of each side are happening, meaning that I now have circumcenters taking place. Okay, so this is a circumcenter. And 3 different ways it can look. Circumcenters in acute triangles happen on the inside, on right triangles on the triangle, and obtuse outside of the triangle. So then we get something like this. What type of triangle would this be? Obtuse. Below 3 perpendicular bisectors create a point of concurrency. The point of concurrency is located at 7,4, and it is a distance of 13 from the vertices, okay? One of the vertices has an x-coordinate of 12. If this vertex is located in the first quadrant, what's the vertex's y-coordinate?
Oh,
So if this is 7,4 right here, this length is 13, this is 12, they wanna know what the y-coordinate would be of this if it's in quadrant 1.
I thought that was a 7, it doesn't look like a question mark. 4 plus 13?
How could you figure that out?
4 plus 13?
Why are you saying 4 plus 13?
I don't know.
Well, if you can give
Because
me a
the-
valid reason why.
13.
Y's,
What?
the Y's.
I wanna figure out what the y is, yes.
So if you're.
You do the distance.
Okay, sort of. Do you have a distance already?
13.
Kind of.
13.
So
So what if I
13
plug
equals-
13 equals
Equals.
the square root of, what's your x's?
7 minus 12
7 minus 12
You're so smart,
squared
Brandon.
plus
4 minus x.
4 minus y
why?
squared, right?
y.
How do you get rid of a square? Root.
Radical it.
You square it, yeah.
You radical
Boom, boom, what's 13 squared?
169.
169.
Wait,
it.
for real?
Wow.
Yeah, and then you have
I
this.
thought it was like 169.
Then-
Well, it's 169.
Guys, what is, what is 7 minus 12?
-5.
And what's negative 5 squared?
25.
Okay, what do I have to do to square this?
You like break it
Square
up,
both.
and you'll.
Six squared minus
Square
y
4,
squared.
square 4.
No. How many
Wait,
of these
don't
do
you
you
do
have?
this?
Oh my goodness.
Oh, I'm so stupid. So
No,
16 plus y squared.
So this gives you,
16.
this gives you negative 8y, and this gives you y squared, yes?
Thank you.
Okay, now, let's be smart here. Let us bring everything to one side so it's set equal to
One.
0.
Oh.
0. So that you can factor and figure out what y is.
Oh, that's not
You
0.
have to add like terms.
So, let's do that. What's 25 and 6? First of all, let's rearrange this. It should say y squared minus 8y, yes?
Yeah.
What's 25 and 16 add together?
41.
What did you say?
39, 31, 41.
25 by
41.
Caleb, like, already said that
Pause at
before,
41,
like-
but I want to subtract 169 from it. So what's negative 169 and 41?
128.
Negative 1, what?
I have no idea what they're saying.
Or no, it's
I don't know what you're asking.
brain's not that well done.
420. 420.
How about negative 128?
Hey Siri.
That's different.
Didn't work.
Okay, negative 128. Now we need to factor this. Y.
Oh, no.
What multiplies to give me negative 128 adds to give me negative 8?
120.
What?
Wait, what?
What multiplies to give me negative 128 adds to give me negative 8?
Big
Oh, I have no idea.
Well, you need to know something about that.
Discuss, discuss.
Negative 8?
Divide by
My
2.
brain cannot math.
Four.
Sorry.
4.
4 and 32, no.
What?
Do, try like 16.
Good,
Yeah, I'll say
16 and 16 times what gives you 128?
I don't know.
8.
Wow.
Well, take 128 divided by 16, what do you get? 8. Good.
Oh, that makes
Yes,
So
sense.
Brandon,
then which
faster
one's
than a
positive, which
calculator.
one's negative?
It's positive 8 and negative 16.
It's positive 8, it's negative 16, so y equals, stop talking, y equals 16 or y equals what? Negative. Negative 8.
I
Now,
thought we were done with this.
oh heck no,
How
we'll
is
never
this in
go
the
away.
first
Alright.
Now, listen to what I'm asking you. It says, which one would be the y coordinate we're looking for?
16.
Why?
Because it's in quadrant 1 and it's
Because it's in
positive.
quadrant 1, so you have to use some common sense here,
Yeah.
okay? So my answer is y would be 16.
that foundation on it? Sorry.
Listen, you guys should probably pay attention a little bit better.
I normally pay attention. I'm sorry.
Normally.
I pay attention just normally. You take your notes before class.
Circumcenter. Circumcenter is a point of concurrency that is equidistant from each of its vertices. So a circumcenter is a point of concurrency that is equidistant from each of its vertices. That's why when you have a perpendicular bisector, you get a circumcenter. Because perpendicular bisectors create a circumcenter that is equidistant from each of the vertices. Okay? When you are doing something like that, okay, it says, or when we are finding a circumcenter, it's possible because all objects can be circumscribed inside of a circle. Okay, meaning any object that I draw, if I draw a triangle, it's technically inside of a circle.
Really?
If I draw a square or a rectangle or whatever, it's technically inside of a circle because there's always 360 degrees around everything.
Pretty much.
So are we
Makes so
inside
much
of the
sense.
Possibly. So if I put a pentagon, if I draw a pentagon, I can figure out its angles because it's inside of a circle.
Because you're.
Is it the?
That is mind blowing.
I don't.
Calculate the graph. Calculate the graph of the circumcenter of the given triangle. How can I find the circumcenter of this given triangle?
Distance.
What do you know about the circumcenter? It is what?
Equidistant.
Oh,
It's
it would be
equidistant.
2. So on the left side, it would be 2. It would be negative 4, 2. Would be the bisector. You would draw a line on negative, on
So
2.
wait, I have a question.
You
Do you
draw
find
a
the
line.
distance between?
That's parallel to x. Boom.
Would you? Would
It's
it?
McLean style. Boom.
Would it be? Would you find the distance between let's say it's A, B, C? You'd find the distance between A and C, and then A and B, and then find the distance between those two.
Well, that's what I'm asking. Let's talk about that.
Let's talk about it.
Okay, you said you have to find what?
I said, would you find?
Not you. You said you have to find what, Brandon?
Middle.
So
No, I
what
don't-
would, what
No,
that,
Distance is 4.
No.
what would that be
the-
considered?
The bisector
what, Abby?
bisector converse.
The midpoint?
the midpoint,
Yeah.
okay, the midpoint. How do you find midpoint?
You use the midpoint formula?
Which is what?
Or you can just do it in your head.
X plus-
One plus
yes.
y
Two, that is parallel to
Yeah.
x.
and then x two
But it's
plus
opposite.
x one
Yeah,
over two.
X comes on.
Okay. Guys, stop talking. Just stop talking. Because you're not gonna understand. I'm telling you, this is probably the hardest chapter we've done this year. Because this
We'll
stuff,
ever do this here?
no, because this stuff gets confusing in your heads. Once we introduce more than one, it gets confusing. I'm warning you. You have to pay attention.
So as a recap, we find the midpoint of 6, 0 and then negative 4, 4.
Well, sort of, we're talking about that. If I find the midpoint of 6, 0 and negative 4, 4, that would give me what?
The midpoint of the line, right?
No, it would not give me the midpoint of the circumcenter. necessarily.
So
The
the
middle
line.
line. The
It
middle
would give me
line.
the midpoint of that line.
Yeah.
The circumcenter is where all three perpendicular bisectors meet.
So did I kind of say that? You find the distance, you find the midpoint of both of those and the midpoint of those two?
No.
Oh, sorry.
So do you have to draw perpendicular bisectors?
Well, that's what we're trying to avoid, Abby. We're trying to avoid getting out of compass and protractor and drawing stuff. We're trying to say, you can do this mathematically, but we do have to use the midpoint, okay? What type of shape is this right now?
A triangle.
Well, what specifically?
Right.
Right
So where is it going to fall?
Right.
It's on the hypotenuse.
It's gonna be on the hypotenuse, right?
Yes.
Okay, so if I find the midpoint of this line here, like you said,
1, 2.
which would be, what'd you say?
1, 2.
Not one.
Well,
Negative 4, 2, that's parallel to
That's
x.
negative 4 is 2, okay, so 1, 1, 2, okay? If I find that, it's 1, 2, correct?
yes.
Okay. What happens when I find, the midpoint of negative 4, 0 and 6, 0? What do you get?
You get negative 5, I mean 5, no 1. 1,
4.
1, 0,
1, what?
0.
1, 0.
0.
Y.
Okay, so x would equal 1 would be my vertical line, right? Okay.
Why is 1 0?
And,
Because negative,
Don't steal his thunder.
negative 4 and 6 is 2,
I got
divided by
one.
2 is 1, 0 plus 0 is 0.
Oh, sorry.
I got it. So 1, 0, so we have 1, 0 here, we have 1, 2 here, right?
Yeah.
What do you have here?
you have negative 2,
Negative 4,
negative,
2.
no,
Negative 4, 2.
negative 4 is 0, that is parallel to x, boom.
It's negative 4, 2.
Negative 4, 2,
That's what I said.
you said negative 4, 0.
I said, no, I changed it after.
I said negative 4.
Oh, did you now?
Negative 4, 2, okay? So if you take, listen, if I were to draw those midpoints on there, okay? Let's just pretend that I'm doing this perfect.
Facts right now.
So I draw that midpoint of whatever it was, boom, okay, I draw, why is it not drawing?
I don't
Well, how to get the veins?
Because you,
Yes, guys, get
you have it clicked on
You're
like
on
the
the
arrow.
corner.
You have to
okay.
be on
I
the
just made-
marker.
I just made up this
Like
conspiracy.
the one below the arrow.
No, not this one.
Yeah, it's that one.
Okay, so let's say I put a dot there. I want this to be something. That's not how this actually usually works. And let's say I put something there, and then let's say I put it here, because those are the midpoints, yes?
Dan, I really need these.
Okay, pretend with me, those are exactly
I
midpoints.
really need these.
Then you're gonna get out a straight edge, yes?
Yeah.
Then you're gonna take it and you're gonna go like this, right?
Whoa.
And you're gonna go boom, and you're gonna go boom, right? And it should be like whatever that point is right there,
This is a right triangle.
okay? Because this is a right triangle. If it's not a right triangle, it is vital that you do all 3 points because it's not going to fall on the hypotenuse at the midpoint. It's gonna fall outside of it, or it's gonna fall in the center. Do you get what I'm saying?
No.
Okay?
No, I don't.
It is also vital that you do this on graph
paper.
paper. If you don't do this on graph paper, you're never gonna get the right answer.
I have a question right now.
What?
So the reason that the midpoint is not in the middle is because it's in a circle, right? So it's the middle of the circle, right?
Correct.
I get it now.
Wow.
Because
Chloe-
two right triangles make a
So smart.
square, and then the square.
Oh.
Miss
This
Peters,
is
Yes.
so big.
since two right triangles make a square, it would be in the middle of the square.
Correct. See how it all comes together?
Oh,
I see
alright.
the world.
Okay, that is what this section is about. Now, here's why that's important. Because sometimes, when we are like doing things, real world scenario would be this. Let's say Walmart wants to build another store, okay?
What about Target?
But they want it to be equal distance from 3 different locations, right? Because then they get more people to come to that Walmart, right? 15 minutes from each location. They
Yeah.
would have to then find the circumcenter of that triangle that's mapped out on the map to figure out where to put that store. Cause it would be in the center of all those locations, so it would be equal distance, cause if it's the perpendicular bisectors of all those, and it's the circumcenter of those, then that means it's equal distance from each of the vertices, which are those towns. So lots of times when they're doing restaurants and stores and things like that, that's how they decide where to put something.
Wow.
I thought they just picked a place where a lot of
Chick-fil-A,
people go past and
they
see.
put one in-
No,
they put one
there's
in the
strategic
DOA.
neatness
Well,
to
some
it.
people are not strategic
Literally.
because there's some weird stores and weird places, just saying.